Hello there, my name is Florian and I welcome you to IT Tech Tips. Today I'm going to talk about a topic which concerns most of you, keeping your data safe. One way of doing that is using a RAID, which allows for at least one disk to fail and the data will still be intact. In this episode I'm giving you a general overview of what a RAID is, then I will show you the most popular RAID levels, and then I will go into details for each of these RAID levels. Now let's have a look. So what is a RAID in general? RAID stands for Redundant Array of Inexpensive or Independent Disks. So you take a bunch of physical disks or flash storage and treat them as one logical disk. Of course, whenever I say disk in this episode, I also mean flash storage. When you create a RAID, you decide, should it be fast or should it be safe? As a general rule, more speed means less safety for your data, and vice versa. Before I can explain how a RAID works, we must have a look at how a file is stored on your disk. So, what is necessary for you to access a file on your disk? First, you have a bunch of physical disks. They are independent of each other. A layer above that is your storage pool or your RAID, and above that there is one or more volumes, each of which will have a file system. And on this file system you will store your files. In this episode we're having a look at the RAID or storage pool layer. If you're interested in learning about the other layers, leave a comment below the video and I will have a look into that as well. So what are the most popular RAID levels? I will first give you a brief overview and after that I will go into more details. Generally, it's speed versus safety. So we have RAID level 1, which is mirroring. So one disk mirrors the data to a second disk. Then we have RAID 5, which is a stripe set with parity. So you have a bunch of disks and on a separate disk you have parity information. With a RAID 6, which is a stripe set with double parity, it's almost the same as with the RAID 5, you just have two disks with parity information. Then we have the RAID 0, which is a stripe set without parity, and in my opinion it's not really a RAID because it's not redundant, but it's very fast. So your data gets just split and stored on several disks. And we have the RAID 10, which is a stripe set of mirrors. So we have multiple mirrors which are then handled like a RAID 0. The previous overview is just a general principle of how these RAID levels work, and it's valid for all manufacturers. So if I'm talking about the RAID 1, it's always mirroring. If I'm talking about the RAID 5, it's always a stripe set with parity. But the technical implementation may differ from manufacturer to manufacturer. So if you have like a HP SAN or NAS, it will handle the actual storage of the bit or bytes differently than like a Hitachi SAN or NAS. There are various things which can differ from manufacturer to manufacturer, like the location of the parity or the algorithm used to calculate the parity. Caching can be different. Some may support tiering and others may not. And the supported RAID levels on a device may differ as well. It's generally not possible to recover a RAID from one manufacturer in another manufacturer's device or storage system, except they both comply to the same de facto standards, which is almost never the case. Consumer or prosumer NAS from Synology, QNAP and other brands often use a Linux system and MD, so it's basically a software RAID. These RAIDs can usually be read after an appliance hardware crash on just some Linux PC, where you connect the drives with an adapter. But because it's just software, it's usually slower because all the calculations of the RAID happen on the CPU and not on a dedicated controller. With professional storage systems like from HP or Hitachi, they use proprietary hardware controllers. So if the appliance fails, you will need the manufacturer, which is typically very expensive, to restore the data for you. Or you have a second SAN where you can just swap out the disks. But these systems are much faster than just software RAIDs. One thing is really important. A RAID is not a backup. The RAID will not protect you from accidental deletion of files or if you overwrite a file with just some other content. A RAID is just a protection for you from disk failure. Now let's have a closer look at RAID 1. RAID 1 is mirroring. So all data from one disk goes to the other disk. The capacity of a RAID 1 is really bad. If you store something on a disk, you will use the whole storage again on another disk. So you get only 50% of capacity. But on the other hand, the redundancy is very good. It's 100%. If you lose one disk, you will have the same information stored on the other disk. The speed is also good. And typical use cases for a RAID 1 consist of small NAS, for example, in your home, in the home office, or for smaller amounts of very important data because you have a high redundancy, but storing the data is really expensive because you only have half the capacity. So when data arrives at the first disk, it will be copied to the other disk. And that's that really simple system. The RAID 5 is a stripe set with parity. You need at least 3 disks, from which one disk may fail, and only one disk. It's very storage efficient because you will only lose one disk in capacity out of your whole bunch of disks, but you shouldn't use it for large RAIDs. I recommend using it for up to 5 disks and not more. Let me explain why. After a disk crashes, the restore process might crash a second disk. Because when a disk crashes, the RAID has to be rebuilt. And while rebuilding the RAID, all other disks will have a lot of traffic, of data traffic. And this data traffic is bad for the disk, typically. There is only so much traffic a disk can handle. And if you restore the RAID, this may cause another disk to fail, and only one disk may fail in a RAID 5, so you will lose all your data. And that's bad. The capacity, however, is really good. You get like 66% of capacity when you use a RAID 5 with 3 disks, and you get 80% of capacity if you use it with 5 disks. The redundancy is about medium with 3 disks and low with 5 disks. The speed is pretty slow when writing data to the RAID, but it's a bit faster. I would rate it medium when reading data from it. A typical use case for a RAID 5 is a backup storage, where you have a lot of data, and if the RAID fails, it's not that big of a catastrophe. So data arrives on the RAID, and it will be split to 2 of the 3 disks in this example, and the parity information will be calculated and stored on the 3rd disk. Let me remind you, this is just an example. The actual implementation may differ from manufacturer to manufacturer, but the principle stays the same. RAID 6 is really similar to RAID 5, but you have 2 disks containing the parity information. So it's called a stripe set with double parity. You need at least 4 disks, but from which 2 disks may fail. So you can use it for larger RAIDs containing more disks. I recommend using it for 5 and upwards disks. After one disk crashes, the RAID still has redundancy, unlike in a RAID 5, where when one disk crashes you have no more redundancy. If a second disk crashes, you would lose all your data with a RAID 5. With a RAID 6, you have one additional disk for your data safety. The capacity is about medium. you have 50% capacity when using only 4 disks, and you have 75% capacity if you use it with 8 disks. The redundancy is very good with 4 disks, and I would rate it medium if you use it with 8 or more disks. The speed is comparable to a RAID 5. It's rather slow when writing because of the whole parity calculation, but it's a bit faster when reading. A typical use case would be to use it for a large amount of flat space data like multimedia or documents or binaries, software, etc. So the data arrives and it will be split on the disks, and parity will be calculated and stored on 2 disks. Let's talk about RAID 0, the stripe set without parity. You need at least 2 disks from which no disk may fail. So if you have 1 disk failing, you will lose all your data. However, a RAID 0 is very storage efficient. You get all the capacity from all your disks combined, so 100%. You should always only use a RAID 0 together with a backup solution, or if it's just used for temporary data. Every added disk to a RAID 0 generally increases the performance. So if you have 2 disks, you will get the performance of the controller being able to write to both of these disks. If you add 3 disks, the controller will be able to write to the 3 disks in parallel, and this is really fast. The same goes for reading. The capacity is perfect. You will get 100%. The redundancy, however, is non-existent. If one of your disks fails, you lose all the data on all of the disks. The speed is very high, and it gets higher by adding more disks. A typical use case for a RAID 0, which is technically not a RAID, is databases, if you use it with a backup, or caching. Or if you have game data, like for home usage, often in gaming PCs, there is a RAID 0 present for storing your, for example, Steam game data, so level loading gets faster. So the data arrives and will be split to all of the disks in your RAID 0 at the same time. RAID 10 is a combination of RAID 1 mirrors and 0 stripe set without parity. You should have a good understanding of RAID 1 and RAID 0 to understand RAID 10. On the image you see on the left side in gray, there's one RAID 1, and on the right side there's a second RAID 1 in blue. So as I said, a RAID 10 is a stripe set of mirrors. You need at least 4 disks for that, 2 per mirror, from which 1 or 2 disks may fail. I'll explain soon. It's a compromise between safety and speed. It should be implemented in hardware. So a software RAID 10 is not really feasible. You should have specialized controllers for that, and that's also the reason why this is primarily used in enterprise environments, because these controllers are rather expensive. Both mirrors, both RAID 1s, should be on separate controllers. This can also be configured with more than just 2 mirrors, because a RAID 0 can also contain more than 2 disks, so a RAID 10 may contain more than 2 mirrors. This would gain additional speed, but you would lose data safety. The capacity is pretty bad. It's only 50% with 2 mirrors, so the same as with a RAID 1. However, the redundancy is pretty good if you have only 2 mirrors. The speed is also good, so it's better than with a RAID 1 and not as good than with a RAID 0, because when you write data, it will be written in parallel to both of the RAID 1s. Remember when I said 1 or 2 disks may fail? Look at the left side. If one of these disks in this RAID 1 would fail, you would still have the RAID 1. And if you look at the right side, the disks in blue, if one of these disks would fail, you would still have the other RAID 1. So the stripe set, the RAID 0, which goes over both of these RAID 1s, would still have a valid configuration. So if two disks on the left side would fail, you would lose this RAID 1. So the gray RAID 1 would be gone. And as with the RAID 0, if one set is gone, the whole set is gone. So that's why I said one or two disks may fail. It depends on your luck. If you're lucky, two disks in two different sets fail. If you're unlucky, two disks in the same RAID 1 will fail. Typical use case for a RAID 10 is if you have 4 disks and you need more safety and speed than with a RAID 5, for example. So the data arrives and it will be split between both of these RAID 1s. Half of the data goes to the RAID 1 on the left and half of the data goes to the RAID 1 on the right. Let's summarize what we've just learned. You should know your needs and then select the correct RAID level for your specific need. So if you need a really fast storage, you're probably gonna use a RAID 0 and have a good backup. And if you need a really secure storage, you're probably gonna use a RAID 6. In more professional environments, you create multiple RAIDs, each RAID suited for a specific need. As I mentioned before, you should not confuse a RAID with a backup. A RAID will not protect you from accidental deletion of a file. It's just a way one or more disks, depending on the RAID level, are allowed to fail, so you have less dependency on a backup regarding disaster recovery. But you should always use a backup as well. At the end of this video and on the top, I will also link my video regarding backups. As a general rule of thumb, the faster the RAID is, the less redundancy you have. So that concludes the episode for today. I hope you've learned how to keep your data secure. If you liked this video, please subscribe to this channel and ring the bell so you're notified about future episodes. If you have any suggestions, leave a comment below. Thanks for watching, see you next time.